Hey everyone, let's start talking about NumPy arrays, how we can create them, and the important attributes associated to them. Let's get started. You should already have NumPy installed, but if you don't, remember that the command is pip3 install NumPy. Assuming that you have it installed, we'll import NumPy as np. Now every time that we want to reference a NumPy function, we'll use this np first. The main purpose of NumPy is to use the multi-dimensional arrays. Let's create an array now. We'll say array A. We'll reference the NumPy package by typing np, and then we'll use the method array. We'll put parentheses, and this function takes in one argument to create an array. So that means we need to pass one sequence to this function. A sequence in Python is just something like a list or a string. We'll use a list for this example. We'll create a simple list, and we'll pass in 1, 2, 3, 4, 5. Now if we drop down and type in print array A, we'll save the file and open up a terminal. Executing the file using Python 3, and the name of mine is NumPy arrays lesson.py. We see that we returned a simple array using NumPy, but this looks a lot like the list that we passed to it in the first place. Right now, we may be tempted to just drop down and say print list of 1 through 5. When we save and execute this, we should get a return that looks very similar, which we do. So what's the point of using NumPy to do this if we can just create lists to contain the values that we want? The first reason why we might want to use the NumPy array is that the operations using NumPy arrays are a lot faster than a Python list. This is because a NumPy array is homogeneous, and that just means that it has one type of data in it. If we wanted to add an element of a different data type to this list, we could. So we'll pass in my name, Derek. When we save and execute this, we should have no problems, which we don't. This is because Python is a dynamically typed language, and that just means that we don't have to explicitly state the data type of each variable whenever we create it. This is an awesome feature if you're dealing with heterogeneous data types because it's built directly into Python. But if you're not working with heterogeneous data types and you have a homogeneous data set, it actually slows you down having that ability. There's a long explanation of why this is, but in short, Python needs more data whenever we don't explicitly state the data type. NumPy arrays don't require this extra memory because they're a homogeneous data type, and that just means that the things that we put into a NumPy array can have operations performed on them much quicker. If we were to add that string to our NumPy array, we might get some unexpected behavior. So let's see what happens when we add Derek to our NumPy array. We'll save the file and execute. It may look like that we get the result that we want. However, if you look closer, it's not the result that we expected. Instead of having 5 numbers and a string, we've turned all of these into a string type. This likely isn't what you want to do. However, this is how NumPy handles the situation. Each of these elements can be a string, so that's why NumPy creates a homogeneous array of all strings. The string Derek cannot be an integer value. That's why the entire list can be of integer data type. If you're working with heterogeneous data, go ahead and stick with the Python list. Let's just work with integers for this example. So we'll take out this string and save our file. The next important note about NumPy arrays is that they have dimensions. We can see these dimensions whenever we access the NumPy array attribute shape. So let's look at the dimensions of this first array. We'll drop down and say print array A. We'll access attributes using a period, and then we'll say shape. We'll execute, and we see that we returned a tuple with only a 5. A NumPy array shape will have a tuple where the first value represents the rows and the second value represents the columns. We only have a one-dimensional array here of the length 5. So this has a shape of 1, 5. We don't see that here because the 1 isn't explicitly stated, but let's see how we can make a multi-dimensional array. We'll drop down and say array B is equal to NumPy.array parentheses, and now we need to be sure to only pass one argument to our NumPy array function. We may be tempted to create 2 lists like this, 1, 2, 3, 4, 5, and then a second list of the same values. However, in this case, we're passing 2 arguments to our NumPy array function. We have the first argument here, and then the comma denotes a new argument, so the second argument would be here. Therefore, we need to put these all into one list value and create one argument. We can do that with a second set of square brackets. So we'll include all of these in one set of square brackets. Now we have one argument that we're passing to the NumPy array. This is just a Python nested list, and it will create a 2-dimensional array of the length 5. We'll see that array now. So we'll say array B, and we'll print that to our terminal. So now, like I said, we have 2 rows and each row has 5 in the length. If we were to change this to print the shape of this array, we should be returned a 2, 5 in a tuple, which is exactly what we get. What we should take away from this video is that a NumPy array has a homogeneous data type, and that just means that every element is the same type in the array. Each array also has a shape, and we can access the shape with the shape attribute, and it's returned to us in a tuple, where the first number is the number of rows and the second is the number of columns. If you understand how to create NumPy arrays and feel comfortable with the shape of an array, then feel free to skip the next project video. If you would like more practice, we'll cover it in that one. I'll see you in the next video.